Polynomials, to identify and classify polynomials and their degrees. That's the objective of this lesson. Let's take a look at this scenario. On construction sites, workers and visitors are required to wear hard hats for protection. If an object is dropped from above, it may injure an unprotected person on the ground. The velocity v of a dropped object can be determined by using the formula v squared equals 2gs, where g represents the acceleration due to gravity and s represents the distance the object falls. Okay, so this is a good example of a polynomial equation. Okay, and let's see what we can find out. As you know, the expressions like b squared and 2gs are called monomials. Okay, let's recall the definition of a monomial. A monomial can be a number, it can be a variable, or a product of numbers and variables. That's our definition of what a monomial is. Expressions that involve variables, okay, in the denominator or a fraction or variables with the radical signs are not monomials. Okay, again, let me read that again. Expressions that involve variables in the denominator of a fraction or variables with radical signs are not monomials. Okay, good example is 3x plus 2 is not a monomial, 5 over m is not a monomial, radical a over b are not monomials. The reason why 3x over 2 is not a monomial is because of the addition sign. Okay, instead of being a product, it becomes a sum. So the addition sign prevents it from becoming a monomial. Okay, the variable in the denominator in this case, okay, prevents 5 over m from becoming a monomial, and since the variables a, b are under the radical sign, okay, this is not a monomial as well. Okay, so those are some examples of monomials, some examples of non-monomials. Let's take a look at this. An algebraic expression that contains one or more monomials is called a polynomial. So when you talk about a polynomial, okay, a monomial is considered a polynomial. Okay, so a polynomial is a sum or difference of monomials. A polynomial with two terms is called a binomial, and a polynomial with three terms is called a trinomial. Poly means many, okay, bi means two, tri means three. Easier way to remember this. Okay, but also don't be confused. Even though poly means many, okay, a monomial, which is only one, is considered a polynomial. So a polynomial is a sum or difference of monomials. Polynomial with two terms is called a binomial, and three terms a trinomial. Okay, let's consider this example. Determine whether the given expression is a polynomial. If it is, classify it as a monomial, a binomial, or a trinomial. Okay, 3x squared plus 7x minus 5. There are three terms in this polynomial, so therefore it is a trinomial, three terms. Okay, so having three monomials and the sum of three monomials, it is a trinomial. Okay, look at 3y minus 1 over y squared. If you notice, again, let's go back to the definition of what a polynomial is. It is a sum or difference of monomials. Okay, so therefore this should be a monomial and that should be a monomial for it to become a polynomial. And let's take a look at 3y. 3y is a monomial, but 1 over y squared is not, because you have a denominator, which is a variable, which makes it not a monomial. So 3y minus 1 over y squared is not a polynomial because 1 over y squared is not a monomial. Okay? Now let's consider this. The degree of a monomial is the sum of the exponents of its variables. Following chart shows how to find the degree of a monomial. Again, it is the sum of the exponents of its variables. Let me highlight that. Okay, so it is the sum of the exponents of its variables. Let's see how this works. Let's look at this chart. we have z, okay? The monomial z, okay? And of course, we know that z is also the variable, and the exponent of z is 1. Therefore, the degree of this monomial is 1, okay? If you don't see a visual number, okay, on top of z or a superscript of z, it is understood that it is 1, okay? Negative 3c squared, the variable of negative 3c squared is c, the exponent of c is 2, the degree of this monomial is 2, okay? Let's consider this monomial, 2/5 m cubed n to the fourth. The variables are m and n. The exponent of m is 3. The exponent of n is 4. We simply add the exponents. The degree of this monomial is 7. And lastly, 0.62 p cubed q cubed. Okay, variables are p and q. The exponent of p is 3. The exponent of q is 3. We simply add the two exponents. So the degree of this monomial is 6. Okay? Okay. So a monomial like 7 that does not have a variable associated with it is called a constant. The degree of a non-zero constant is 0. The constant 0 has no degree. A few definitions that you need to remember. So if you have a monomial that is 7, okay, an example only, and it is not associated with any variable, okay, so if it does not have a variable associated with it, it is called a constant, okay, and the degree of any non-zero constant is 0, okay, and the constant 0 has no degree, okay. So when you say 0 and they ask you what's the degree of 0, it has no degree, okay. Okay, let's move on. So a polynomial also has a degree. Remember, we talked about the degree of a monomial. So the degree of a polynomial is as follows. The degree of a polynomial is the same as that degree of the greatest, the degree of the term with the greatest degree. Sounds confusing? Let's find out how it works. Let's find the degree of this polynomial, x squared plus xy squared plus y to the fourth. Okay, let's take a look at each of the terms of this polynomial. This polynomial is a trinomial. It has 3 terms, x squared, xy squared, and y to the fourth. Okay, first, find the degree of each term. Okay, we know for a fact that x squared has a degree of 2. Okay, xy squared has a degree of 3. Why? Because x has an exponent of 1, y has an exponent of 2. You simply add the exponents, so it equals 3. Y to the fourth has a degree of 4. And remember, okay, y to the fourth now has the greatest degree of all the terms. So that means, okay, the degree of this polynomial is 4. Okay, so again, get the degree of each term. Okay, find out which term has the greatest degree, and that will be the degree of your polynomial. So the degree of this polynomial is simply 4. Okay. Doctors can study the heart of a potential heart attack patient by injecting dye in their vein near the heart. In normal heart, the amount of dye in the bloodstream after t seconds is given by the polynomial negative 0.006 t to the fourth plus 0.140 rho t to the cube, t cubed minus 0.53 t squared plus 1.79 t. Find the degree of this polynomial. Again, we go back to what we did in the last example. The degree of negative 0.006 t to the fourth is 4. Okay, the degree of 0.53 t squared is 2. Let's go back to 0.140. The degree of 0.140 t cubed is 3. And the degree of 1.79 t is 1. And if you notice, okay, this polynomial has 4 as the greatest degree of its terms. Therefore, this polynomial will have a degree of 4. Okay? Evaluate. Okay, last example. We want to evaluate 6x squared minus 5x y if y equals negative 2 and y equals negative 3. Remember what we mean when we say evaluate. Evaluate means to simplify, to substitute and simplify, 2 steps. So in this case, we need to substitute the values of x and y to this particular expression. Okay, so we substitute x to negative 2 and y negative 3 to y. So we now have 6 times negative 2 squared minus 5 times negative 2 times negative 3. So we simply substituted or replaced x with negative 2 and y with negative 3. Then we simplify further. Oh, before we go there, it's here first. Okay, negative 2 squared is 4. Okay, and we know that a negative times a negative becomes a positive, so this becomes negative 5 times 6. Using the order of operations, multiply before you subtract, this becomes 24 minus 30, and the value of this particular expression when x equals negative 2 and y equals negative 3 is negative 6. That's how we evaluate this particular polynomial. Okay? Lesson's done. Write your summary on Google Forms and a question you may want to ask in class about this lesson. Thank you.